speed and velocity, as you can see up on the board. And for bell work, we're going to watch a little video, and then you guys are going to answer a question on So Creative. So you guys can go ahead and log on to that. Let's watch this video real quick. It's pretty neat. We're just gonna play.
1976 och 1958.
Yep.
Jag tror inte på världsrekorden.
It's gonna turn to English soon,
Hittills
don't
har
worry.
den här mannen alltid överträffat alla
But
förväntningar.
it's in Swedish right now, in case you were wondering.
Ja, varför inte ett världsrekord? Det är perfekta förhållanden.
The 200-meter dash is a sprint that requires tremendous amounts of athleticism. In 2009, here in Berlin, Usain Bolt broke the world record for the 200-meter with a time of 19.19 seconds. How fast was he going? Well, that depends on how you look at it. How fast Usain Bolt was going depends on if you look at his average speed or his average velocity. Speed is given by the distance out.
Okay, so this is the equation. Speed is distance by time, and velocity is displacement over time. So now if you guys go on to So Creative, and then send your answers in, and we'll go over what you guys think the difference is between velocity and speed, given on the two equations. So these are what you guys thought the difference was, and then we're going to go and finish the video and he explains what the difference is. So someone said, speed involves total distance covered, while velocity depends on location. And that's very correct. It does depend on location, where you are from the starting point. Velocity includes direction and is a vector, while speed is simply a scalar. That is also correct.
Well,
Very impressive.
you know your
knowledge.
physics.
And one is the displacement and the other is distance, I think. That is correct too. So distance is how far and displacement is the location. So it's just like the same wording as that. So we're going to go ahead and rewatch the video because it's kind of fun to watch them run. So we'll just start that over. Okay. Is it playing? Nope.
1976 och 1958. Jag tror inte på världsrekorden.
Hittills har ju den här mannen alltid överträffat alla förväntningar. Så att, ja, varför inte ett världsrekord? Det är perfekta förhållanden.
The 200-meter dash is a sprint that requires tremendous amounts of athleticism. In 2009, here in Berlin, Usain Bolt broke the world record for the 200-meter with a time of 19.19 seconds. How fast was he going? Well, that depends on how you look at it. How fast Usain Bolt was going depends on if you look at his average speed or his average velocity. Speed is given by the distance over time, whereas velocity is given by the displacement over time. We'll look at each of these separately. First, let's look at his average speed. When considering Usain's average speed, we consider the entire distance he ran around the track, which is a total of 200 meters. So we get that the average speed is 200 meters over 19.19 seconds. This gives us a total of 10.422 meters per second. Now let's look at velocity. When considering Usain's average velocity, we only consider the distance between his starting and ending position, which is about 115 meters. So we get that the average velocity is 115 meters over 19.19 seconds, which only gives 5.993 meters per second. And how you look at it, Usain Bolt's record is still an incredible feat.
And that's it. You gotta work on your bow work. We're gonna go ahead and we're gonna talk about it. We're gonna take notes on speed and velocity. Here's your worksheets for today that you can add to your folders. And we're just gonna watch this funny little clip that talks about what somebody mentioned in theirs, which is vector and what that means. So
Oh boy.
here we go.
Okay, I'm really high maintenance, but could you talk?
I'm applying for a new film phone. Go by the name of Vector. It's a mathematics. Quantity represented by an arrow with both direction and magnitude. Vector! That's me, as I'm committing crimes with both direction and magnitude. Oh yeah! Piranha! Oh yes! Firefly piranhas. Never seen one before. Now you have my attention. Oh, ah! It's so difficult sometimes to get going.
Okay, so there's that.
He makes me
Just a funny
so
little
uncomfortable.
thing. Yeah, he is.
It was icky.
You guys see that okay? Okay. So, vectors are quantities that have what?
Both direction and magnitude.
Exactly. And so that's what we're going to be talking about with the difference between speed and velocity. Speed is a scalar quantity, which means it only has, it doesn't have direction, it's just something that it is. Well, velocity has a vector. It needs a direction. So when we're talking about velocity, we're talking about like miles per hour to the west or to the south. Like it needs a direction. It needs to be going somewhere. And so for those two equations, we're just going to write them up on the board so when we get to our examples that we have them. Speed is the distance over time. And this is something that we're going to have to remember because it's something we're going to be using for the rest of the year. And velocity is displacement. I spell this wrong because English is not my thing. Over time. So those, and whiteboard doesn't like to stay up, so we're just gonna set it there. Speed is the distance that something is traveling per unit of time. It shows how fast an object is going, and velocity shows the measurement of how far away it is from the starting point. So examples of speed that we're like used to are miles per hour. Where do we usually see that?
In my car.
Exactly. We see that all the time. It's all around us. So we're going to do a couple examples. So the first one says, if you want to ride your bike to the nearest park, the park is 3 miles north of your house and it takes you 35 minutes to get there. What is your speed and what is your velocity? So we're first going to find the speed. Seth, what is the distance in this?
3 miles.
Exactly. And what is the time?
35 minutes.
Okay. Does someone want to pull out their calculator and tell us what that is? Minutes. We're gonna pick very nice math numbers.
It's 0.085 miles. Well, 86.
That's
0.086
in miles,
miles
per
per
minute.
minute.
Minute. Okay. And then, so for the velocity, what is that? Who wants to tell us what the displacement is?
Is it still 3 miles?
Should
Yep.
be straight north, yeah.
And then the time is still 35. So in this example, the speed and the displacement is the exact same. Now we're going to do one more example. This one is a little bit different. So let's read it and then we'll draw a picture to help us understand what it's talking about. So it says that you're going for a walk and you're going around your block. So you start at your house. So you start right here and you walk around your block. And you end back at your house. The walk takes you 54 minutes. And you end up walking 1.8 miles. Okay, so now we're also going to try to solve for the speed and the velocity. So who wants to solve the speed? Ashley, do you want to do that?
Sure thing.
Okay, what is the distance in this one?
1.8 miles.
Perfect. And what is the time?
54 minutes.
So what is our speed?
Do you want it in fractions or decimals?
You can do it in either one.
Okay.
Probably decimals makes more sense to us. But
Okay. So you are going 0.033 miles a minute. Holly is crawling around the block.
It's 2 miles.
maybe you're the grandma in this situation. Okay, so
You're just
if we're
really
looking for
enjoying
the velocity, what is the displacement going to be? Well, zero. Yeah, because we ended up back where we started. And then we went 54 minutes. But our velocity ends up being zero because we ended up back where we went. That's like a unique situation. It's pretty common, I guess. I don't know. But now we're going to do a little activity where each of you are going to write your own little scenario on here. And you're going to solve it, and then you're going to pass it over to the next person. And they're going to try to solve your scenario and see if they match up with the answer that you write down. And we'll just keep this up here so you guys can see the equations if you need to. We're just going to take a couple minutes on this exercise.
I think I made this more complicated than I actually know how to solve, but I'll just give it to Seth.
And then just write the answers that you get on the back of the paper and then switch it over to the person to your left. Oh, that's super good. It's okay.
Ooh, I'm not messing around. I was speeding in my car. Way to go. Okay.
5 miles in 5 minutes.
Yeah.
So you're
Wait,
going
so
60
the-
miles per hour?
Yeah, that's illegal where I live.
I mean, unless you're like on some back roads.
No,
Then there's
ma'am,
no
there are
cop.
no back roads
Oh.
in Provo.
That is true.
How do you find the iPod?
Oh, you did a hard one too. Your calculator on your phone.
I don't need it.
Okay.
Because Seth remembers physics. I
Yeah.
haven't taken it in 3 years.
Taken 2 calculus-based physics class in the last year.
Oh. I can't wait to
Grody.
take that class.
It's actually super fun. You should get Dr. Pace.
A squared
Dr.
plus
Pace.
B
Just,
squared.
or you
Oh,
could
I
get Nathan's
remember.
older brother.
He's gonna talk too smart, I feel like.
Okay, sorry.
Dr.
Wiggins?
Wiggins?
Wiggins? Yeah, I work with his sister. Both of them, actually. Fun fact. Okay, you guys ready to switch them?
Almost. We can switch it though.
Okay. And then I'll give you about 2 minutes to solve that.
Thanks.
Okay. Because we're
I need
running
to
out
find-
of time.
I need to find the answer to my problem. Okay.
Mine's super easy.
Okay, cool. Sorry.
I don't even know. Just write some answers down. It's not like I'm in a grade. Are we about finished?
Yeah.
Yeah.
Most definitely. Okay.
Got that.
So now we're going
We're gonna
to
sprint
go
into
back
the
onto
park.
Serve Creative. And do you remember those 3 questions that you guys were getting at the first? We're going to go ahead and answer those now to finish up the class before
Okay.
it ends. So you guys can just get back on there and it should be up. Tell me if it's not right. And the passcode's still the same. Pick it 6528.
Neat. Okay.
I got 2 students in. Seth, how you doing?
Getting there.
Okay.
I'm trying to do it because it was still just saying that,
Oh.
yeah.
Oh, that's nice because it tells me. Thank you for doing that. Okay.
Oh.
Wait. I don't like physics. You're a good teacher though.
Just put some answers.
Okay.
We're just
I want to get it right though
Oh,
because I'm prideful.
You got this. You need the fun little equations.
Oh wait, that's easy. Okay.
I tried to make them
Yeah, no, you're good.
with numbers that work out.
They do. You're good. I was just overcomplicating. it.
too. Maybe I worded it weird.
No, you didn't.
You guys can let me know on the last
Submit.
question.
I got it right.
Woohoo! Seth's killing it. So is Ashley. I'm just gonna. Kenzie's
Go.
got it. Woohoo! You got it right.
I got that one wrong. Okay.
It's okay. This isn't
Shake
going
it
on your
off.
grade or anything.
I'm so stressed.
I'm just
I
using
forget
it.
that I don't get graded on this. I'm just so used to it.
I am just using it to see what I need to go over again tomorrow in tomorrow's lesson. Okay. Did you get your last answer?
Oh, I should know that without.
You guys can pack up and go home now.